Hey everyone, continuing with our complex numbers, we'll be looking at another feature of a complex number, the argument. In short, arg of z if z is a complex number. So what is the argument of a complex number? Essentially, the angle that it makes between the complex number and the real axis. How is it measured? It's exactly the same as it is measured in the Cartesian plane from the positive real axis, the positive x-axis, and then anti-clockwise. However, in the complex number, it's not really however, it's more like it's not really used, not really talked about often, is that we can actually also measure from the positive real axis anti-clockwise. What's the difference? Similarities are the same. Anti-clockwise is still positive angle. Clockwise will give you a negative angle, which means that if I were to measure from here to here, the angle is pi over 2 or 90 degrees. If I were to measure clockwise to pi over 2, this will actually give me an argument or angle of minus pi over 2. Alright, so this matters because the principal range of an argument is actually between minus pi to pi, inclusive of pi only. So let's say I have theta as the argument is between minus pi and inclusive of pi. So this is the principal range. You should, as much as possible, convert your arguments to fit inside this principal range. In fact, you can. Alright, let's say you have an argument and you calculate it to be 4 pi over 3. Right? So 4 pi over 3, you know that it's over here. Right? You measure from clockwise direction, you're going to end up here. So this is will give an angle of pi over 3. Then the argument of this complex number, because not in the principal range, what can you do? Now I look at it from the other way around. The clockwise direction, pi minus pi over 3 is 2 pi over 3. So anti-clockwise, in the clockwise direction, minus 2 pi over 3. So we can actually kind of write it in another way, where if your argument for complex number is 4 pi over 3, it is congruent or equivalent to minus 2 pi over 3. Alright, this only applies when we talk about argument. But that's not to say that your argument has to be within the principal range. As you can see, your argument can lie outside the principal range. Alright, so you have 4 pi minus 3 over 3 as an example, minus 4 pi over 3. You can even have 5 pi as your argument. So 5 pi as an argument, basically start from here. You go one full round, 2 pi. Another full round, 4 pi. And one final last half a round, it's finally 5 pi. You notice that it's congruent as having the argument as pi. Alright, so this is argument. Alright, so how do we calculate argument? Where we introduce the familiar idea of basic angle alpha. This time round though, don't forget, we now have the negative angles, which denotes the fourth and third quadrant. So again, we also come back to the idea of quadrants as well. Let's take a look at each quadrant. If your argument, or rather if your complex number is in the first quadrant, let's say we have 2, 1, and this is your complex number, notice that the angle, the argument, is the basic angle. And I'm pretty sure that you guys can know how to calculate the basic angle. If you notice that the basic angle is simply in a right angle triangle y over x. So for the first quadrant, your argument, let's say a complex number z, equals to tangent inverse y over x. Now let's take a look at the second quadrant. Let's say we keep 2 and 1, we now look at minus 2 and 1. Your argument, alright, or let's take a look at the basic angle first. The basic angle is right down here. Your argument comes from here all the way to here. So what is the argument for the second quadrant? Pretty much you can tell right? You have pi minus tangent inverse y over x, more specifically modulus x, because x is negative. All right. Alternatively, if you want to not play with the modulus, pi plus tangent inverse y over x, because, well, tangent inverse y over x in this case would give you a negative angle. Pi plus a negative angle would then give you the argument. But what I like to think of it this way is basically in this second region, you know that your complex numbers of the form minus x plus iy. First region, first quadrant is x plus iy. Alright, so we can write it this way as well. But main thing, x is a length, y is a length. Basic angle is tangent inverse y over x, and then play accordingly. Now, for the third quadrant, I'm going to use a different colored pen. Let's say black. Let's start with the easiest one first, fourth quadrant. Now in the fourth quadrant, we have 2 minus 1. Notice that the angle is basically the basic angle, but you're measuring it in the clockwise direction. Therefore, in the fourth quadrant, your argument of z equals to minus tangent inverse y over x. Again, in the fourth quadrant, is of the form x minus yi. So your argument is basically the basic angle, but the negative of it. Now, the third quadrant, we now have both negative, so negative 2, negative 1. The argument, gonna erase the fourth quadrant. Now your basic angle is right down here. Your argument starts from here all the way to there. Now what you notice is actually the same thing as the second quadrant, but now it's the negative. Alright, so you notice that your basically is minus pi plus the basic angle, because the angle, basic angle is always positive. Minus pi from here to here. Now you come back with your basic angle. So the argument for third quadrant in the principal range is minus pi plus tangent inverse y over x. Again, third quadrant, minus x minus iy. Alright, so that is how you calculate the arguments of a complex number with respect to their basic angle and the quadrants that they lie in. So to recap, first quadrant, alpha, argument of z equals to your basic angle. Fourth quadrant, argument of z equals to minus the negative of your basic angle. Second quadrant, argument of z equals to pi minus the basic angle. The third quadrant, argument of z equals to minus pi plus the alpha. You notice that the third and second quadrant, the arguments are actually the negative of one another. Similarly for the first and fourth quadrant as well. Alright, so this is the argument for a complex number, and this is how you calculate it in the Cartesian form.